Hello. So, welcome to the live session for this course, an introduction to cardiovascular fluid mechanics. We have already completed all 4 weeks of this course, and for the queries, we have received 2 queries until now. So I will address those queries, and if you have any more questions, you can post in the chat group until then. Okay, so the first question was, what is the importance of fluid mechanics in cardiovascular system? So if we look at the cardiovascular system, it is basically a very sophisticated plumbing system. You have a number of pipes of different diameters. So the largest pipe here is aorta and vena cava, which have diameters of the range of few centimeters to 2 to 3 centimeters in diameter. Then you have a smallest diameter pipe, 10 micron diameter pipes, which are capillaries, or you can say those small tubings. So the size range is varying from few microns, so say 10 microns to few centimeters, 2 to 3 centimeters, so of the order of 1 centimeter. So we can say from 10 raised to the power minus 5 meters to 10 raised to the power minus 2 meters. 3 order of magnitude difference in the pipes. The difference from other common, our day-to-day plumbing systems that we see is that the flow is, the pipes in this system is pulsatile. Now, in this piping system, we also have a pump which is heart, and heart has basically 2 pumps, one sending the blood to circulatory system, the systemic circulation, and the other pump sends the blood to the pulmonary circulation. And apart from that, we also have valves. So 4 heart valves, which are basically the aortic valve, pulmonary valve, which are between ventricles, and the artery that takes blood from heart to the systemic or pulmonary circulation. And then we have 2 valves between atrium and ventricle. So they are mitral valve and tricuspid valve. So all such 4 valves, they are all one-way valve. And finally, you have a very special or smart fluid, which is blood, which knows when to a certain extent, it knows that when the blood flow needs to stop. For example, platelets get activated above a certain shear stress and thrombosis starts. So all this is basically a very sophisticated plumbing system. Now it helps in say pathogenesis, diagnosis, management, and treatment of cardiovascular diseases. By pathogenesis, I mean the development of diseases. So you see this on the slide. You see this circulatory system. This is for a mouse, but nonetheless it shows by the gray colors, which are numbered, the locations where atherogenesis can happen, where the plaque formation can happen in the arteries, and this plaque formation can result in stenosis, whereas the may result also in ischemia. So the blood flow, required blood flow to a certain organ or certain tissue may not be adequate, and that may result in some cases problems, for example heart attack or stroke, depending on which artery the atherosclerosis is present. So you can see that in this system, the gray color is present, or atherosis. The location of atherosclerosis is where the arteries or the geometry of the arteries is complex. So it is there are curvatures. You can see here there are curvatures here. there are bifurcations, there are curvatures, most of these geometrically complex places. So if we do fluid mechanical analysis there, in these locations the shear stress is low. Shear stress is basically that if you have a surface, or on this surface the force on the along the tangential direction. So that means that if the shear stress is not sufficient, then the chances of plaque formation or chances of depositing some of the fats or solids or other things present in the blood, they might get deposited on the vessel walls. So the disease can develop. Then diagnosis of diseases, for example, the common technique angiography is basically that you use a flow measurement technique. You introduce a dye and do the X-ray analysis or X-ray imaging and find out where the flow is happening. And then management of diseases because it is a flow system. So whenever, I mean, one of the requirements is that the adequate flow is reaching to all the tissues or organs. So at all the stages of cardiovascular diseases, fluid mechanical behavior is important, of course, with other factors such as biochemical factors, mechanical factors, and biochemical factors, and so on. Then development of the biomedical devices which are essential or which help in management of cardiovascular diseases, for example, artificial heart valves or what we call prosthetic heart valves, and and the pumps that can assist the left ventricle in the supply of blood in systemic circulation. Again, this is important. Then another new and emerging area, what is called, or it has many people have been working on it for past 2 decades or so, what is called patient-specific modeling. So the geometry of the arteries, for example, carotid artery which supplies blood to brain and face, or the coronary arteries which supply blood to heart tissues. Their geometry is different in different persons depending on their age, depending on their health conditions, depending on their gender, depending on their race, and so on, depending on their geographic location as well. So one might need to look at, because one size may not fit. Also, one need to understand the specific groups and find out the blood flow patterns or geometrical patterns and what are the hemodynamic factors that can be important there. So, the patient-specific modeling basically refers to that the medical practitioners or clinicians, they can get the 2-dimensional or 3-dimensional CT images, and from that the complete geometry of the arterial segment where the flow is required is obtained. Along with that, the physiological data is also acquired. So, for example, blood flow, etc., can be acquired. And then one can do flow analysis using CFD softwares and find out the questions that need to be answered. Of course, when we are doing this, we need to validate our methodology. So this can be done by 3D printing of the arteries and do some in vitro experiments, say example using particle image velocimetry, which can give you the velocity field in the system. Okay, so there are quite a few. This gives you an overview about the role of fluid mechanics in cardiovascular system. Okay, so let us move to the next question, which is about that is there any experimental method to measure quantity of blood flow or velocity of blood flow in the heart? So there are quite a few methods here, and I have listed some of them. So one is electromagnetic flow meter, which basically works on Faraday's principle that when a conducting fluid flows in a magnetic field, then a electrical potential is generated. So from the flowing blood, one can measure the velocity of the blood, and if the cross-sectional area is known, then one can measure the flow velocity, and such probes are easily available. I mean that they are available commercially, and but the problem in this is that this is an invasive measurement. Then there is Doppler ultrasound technique, which basically is based on sound. That sound goes and it gets reflected from a from, say, for example, flowing blood, and by the difference in the frequencies, one can measure the velocity of the fluid. And the probes for such case, in such case, are both invasive as well as non-invasive. And then the third is the phase contrast MRI technique, or what we call magnetic resonance imaging. So that can also be used to measure local velocity, local fluid velocity, as well as the blood flow. Okay. So there was a question on the forum that some reference books for fluid mechanics. So I have listed down some common books which start with some basics by the book by Fox and others, fluid mechanics. This is quite an useful book, and somebody with the knowledge of class 12 standard mathematics, for example, vector calculus and differentiation, should be able to pick up quite well from there. Or White or Sangel. All three of them are quite good book, and there are number of other fluid mechanical number of other books on fluid mechanics. Okay, there are quite a few lectures on fluid mechanics, or there are quite a few courses on fluid mechanics on NPTEL. So one is I have listed three of them which I am familiar with. So one is by Professor V. Shankar, another is by Professor Suman Chakravarti from IIT Kharagpur, and the third one is by Professor S.K. Som, again from IIT Kharagpur. And there are a number of other NPTEL lectures which you can search and refer to. I am also offering this in this running semester a course on NPTEL on fundamentals of fluid mechanics for chemical and biomedical engineers. That is more about fundamentals of fluid mechanics. So it is a 30 hours course. So you can look at those videos to look at a specific topic. Okay. So let us see if you have more questions. Okay, so this question is about the format of examination, description or OMR, how many questions and duration. So the examination will be there will be no question which will be descriptive. Most of the question, all of the questions will be MCQ type, which is multiple choice type question. You may get few questions fill in the blanks type, but in that case you please read the instructions carefully, so that there is no, because the answers to such systems are keyed in the system, and they need to be answered in a particular format. So if there is a fill in the blanks type question, do not put any comma or number if it has not been asked. So please read the instruction carefully if it is there. And multiple choice questions can be saying one answer correct or more than one answer correct. This will be indicated in the question. The questions will be typically about I think it will be about 40 questions. The duration, etc., I think it will be communicated to you on the forum. Okay, so the next question is that what is the provisions of research in this area for a mechanical engineer? Is the experimentation can be done in engineering institute? So, of course, probably the question relates that can the some research be done in an engineering institute where there are no interaction with the medical practitioners. So answer to that is of course, because when we are looking at say if we treat cardiovascular fluid system like a fluid mechanical system, then we can of course do some research. So some of the things that we might need to or we should be doing is that we can try to develop pumps or prosthetic heart valves, the basic models of them, which are working sound fluid mechanically. Of course, when it comes to clinical trial of it, you need to get in touch with medical practitioners or the labs where those trials can happen. But once you start some initial research in this area, I think you will be able to connect with cardiovascular surgeons or other people who are working in this area for clinical trials, etc. Okay, so I think there is a lot of scope, especially in India, that you can work on the research. For example, two things that I can suggest that one is prosthetic heart valves, another one is a pump which can mimic the heart, the flow in the heart, and then the third thing is heart and lung machine, because most of the things that we get as of now are imported, so we can develop systems uh, which can reach up to such level that they can replace the imported items, then it will be great, I think. Another thing that you can probably look into is, for example, flow in flexible tubes. So if you can develop or if you can using 3D printing, you can develop some or create some flexible vascular tubes or the flexible tubes which can mimic vascular vessels and understand and collect the data for flow behavior in such systems, then that will be again quite helpful. Okay, so the next question is that in mathematical modeling of blood flow in a specific artery, should we consider the artery as a finite tube or infinite tube? That will depend on what kind of modeling you are doing. So, for example, if we, what we have done, say, a Wormersley solution we developed for pulsatile flow in a rigid tube, there we considered the tube to be a infinitely long tube. But if you are doing, say, computational fluid dynamic modeling, then of course your domain needs to be finite. And that will be the ideal thing to do because the arteries will have finite lengths. What is important there, that what you could do is that the boundary conditions that you use in your system, they should be some based on some physiological data, and you should be able to get such physiological data from the literature. For example, if you are planning to model flow in a carotid artery, then what is the flow rate profile or what is the pressure profile at the entrance of carotid artery? what is the flow resistance being offered by the vascular system downstream of this artery. All these things if you can get, then you can use that model to find out the blood flow in the arteries, the velocity distribution, the shear stress and all those things you can find out. So please post your questions. If you have any further questions, you can post it, say in next 5 to 10 minutes. So the question is about some sites to get data on the. I I do not know any specific site. You might need to do a bit of literature survey so that you can get the data on the on, on blood flow, or you can contact some cardiovascular surgeons uh, and the radiologist team working with them. They can also help you with the data in your city or in your locality. You can look at a software which is named as Simvascular. It is an open source software. So I just talked about patient specific modeling, and that software can do end to end modeling, that you can import the geometries there and then do the convert it to three-dimensional models, and from three-dimensional model you can do the CFD simulation including structural analysis. So you could try your hand there, and there you might get some data in the tutorial examples. Can I type it from here? So I have just typed the name of the software, which is called Simvascular. I think there are some tutorials also available on YouTube. So please post any further questions in next 5 minutes. Okay, if there are no further questions, then we can wind up it in next few minutes. Uh, if you have any quick questions, you can still post it in next say 1 or 2 minutes. If not, then if you have any questions anytime, you can drop me an email or you can post it on the forum. Okay, since there are no further questions, we will close the session now. You can always drop an email to me at guptar@iitg.ac.in or you can ask question in the forum. Thank you.